Hello everyone, welcome back to the channel. This side Aman Singh here. Now we are going to discuss on a new topic which is nothing but APIPA. APIPA is nothing but automatic private IP addressing. As the name suggests, automatic private IP addressing. So uh, when you are having your laptop and when you go to the office and when you connect your laptop to the network and somehow there is an issue with the DHCP server and your laptops are configured to get an IP address automatically. So when your when your laptop, your host machine tries to talk to DHCP server, but it doesn't get any kind of response. After to keep on trying, it sends the DHCP discover message, but it doesn't get any reply. So in that scenario, the Windows OS is automatically takes an IP address from the range 169.254.0.0/16. It is nothing but an IP address range reserved for APIPA. So it's like when the host is not able to talk to DHCP server, this IP address you will be seeing on your laptop. Okay. So now the question is what? Okay, I in this scenario, if you see in my diagram, I can see there are two PCs are there, and the outer R1 is having some DHCP configuration, and is somehow it is not working. So in that scenario, what will happen? The PC1 will keep on sending the DHCP discover message, and unless it uh, tries for certain 5 to 6 times and it doesn't get the IP address. So, but it gets an IP address from APIPA 169.254.0.1, and PC2 also get an IP address 169.254.0.2. So will this PC be able to communicate? The answer is yes, because they are in the same broadcast domain and they are in the same subnet, so they can talk. But what if they want to talk to some different subnet? Will they be able to communicate with the APIPA IP address? The answer is no, because this APIPA IP address is not routable. And here you won't be getting any default gateways. So it's like if you want to talk to another PC within the same network, then you can easily talk. But if you want to talk to another subnet, you cannot talk with the APIPA IP address. Okay, I'm clear. Let's move to the fourth point. The fourth point is like the host uses ARP. What does it mean? If the PC1 is taking that IP address like from 169.254.0.1, then it checks and if the same IP address is assigned to any other PC in the network, because there could be a scenario where there could be 100 of PCs. So each PC should be having unique IP address. So in this scenario, ARP will come in picture. So with the help of address resolution protocol, it will check whether this IP address is assigned to any of the hosts in the network. If no, it will take that IP, it will use that IP address. If yes, then it will take another free IP address, and again it will do the same process. It will check, okay, if this IP address is assigned to any other PCs or any other system in the network. If no, it will take. If yes, it will go for another IP address. So can we use this IP address range 169.254.0.0/16 for enterprise purpose? The answer is no. We cannot use this IP address. It is just meant for failover purpose. If the DHCP server is not reachable, then by default it will get this IP address range from 169.254.0.0. So it cannot be used in any network. It will cause an issues in routing issues. So we should avoid using this APIPA range in the network. So let's start with the lab. I have two PCs, one switch and one router, and I have already configured some DHCP configuration. I have just let's So you might have seen my video on how to configure the DHCP configuration. So let me go through this. It's nothing. On the first line we are just defining the DHCP pool name. I have given the APIPA underscore lab, and the second network 10/24 which you see, it's nothing but I'm defining that this is the DHCP pool range and if any of the PC request DHCP discover, then the you laptop or host machine should be getting IP address from this network. And the DNS server, the client or host machine should get this DNS server 8.8.8, and the default gateway should be 10.0.0.1. Let me show run show IP interface brief exclude unassign. So this is the default gateway, and this is nothing but the router is acting as a DHCP server. Okay, so if you see show IP DHCP binding, right now there is no record of PC1 and PC2, and I will show you show IP, nothing here. PC1 and PC2 is not having any IP address or anything. Okay, so let me show IP. So it is not having any IP address, right? I believe in this GNS there is a limitation. I cannot use this. Uh, I cannot configure it automatically, so I need to assign this IP manually. 169.254.0.1, 255.255.255.0. Okay, so PC1 is configured with this IP 169.254.0.1, and the PC2 let's configure this also 169.254.0.2, 255.255.0.0. Okay, let me make this correction here. It's IP 169.254.0.1, 255.255.0.0. Okay, so now these are having a unique IP address, and if you can see on the diagram, so these are the two PCs which PC1 is configured with 0.1 and PC2 is configured with 0.2, and this is the layer 2 switch, and router 1 is acting as a DHCP server here, but we will shut this interface. Okay, so in the R1 let us shut this interface. Interface pass Ethernet 0/0 shut. Okay, this interface is down. If you see, there is a log message also, it is showing that interface is down. So the first question was like whether this PC will be able to communicate if they are in this range. The answer is yes. Let me ping to another PC, PC2 from PC1. Yes, I'm getting the reply. What if I ping this PC 169.254.0. Let me stop capture, start capture. Let me here remind you later. PC1. So if you see, can reach to ping. I can see that ping request and ping reply packets I'm getting. So ping is successful here. If I clear this IP address, let me clear it on PC1. Clear IP, and I will do the same thing. Clear IP. Now I will request a IP DHCP. Let's see the Wireshark what is happening. Can you see here? just keep on trying DHCP discover message, three messages are sent, and it didn't get any reply here. So because the, let me unshut this interface. No, shut. And now I will do this. I will run this command again, IPDHCP. I am running this command, and if you see, it has sent the DHCP discover message. Then my router is sending the DHCP offer. Then my host machine is again sending a DHCP request, and the router is again replying back to that request message, DHCP acknowledged. So this shows that the handshake process is completed, and my this PC2 has got an IP address. If you he got PC2 has got the IP address of 10.0.0.4. Let's see. So IP, yeah, it has got this IP address. If I try to ping to default gateway, it should work. Yes, it is working. So let me run this IPDHCP here also. Yes, the DORA process is completed successfully, and this PC has got the IP address 10.0.0.5, and it can ping to the default gateway. Show IP DHCP binding. So if you can see, these two IP addresses 4 and 5 both has been assigned to PC1 and PC2. So this video I'm ending here, and this is an important topic. Okay, so you might can interviewer can ask on this. So please be prepare yourself. And thank you for joining, and thank you for watching.